Assalamualaikum and hello everyone. Welcome to video for chapter 4 Introduction to Organic Chemistry for 4.2 Structural Formula. In this video, we're going to learn to define structural formula and illustrate possible structural formula in the form of expanded, condensed, and skeletal structure. So what is actually a structural formula? Structural formula is a chemical formula which shows how the atoms are bonded to each other. So carbon will form 4 covalent bonds, hydrogen and halogen. For example of halogen, fluorine, chlorine, bromine and iodine will form single covalent bond. Okay, so for example, we have carbon. Carbon will always have 4 bonds. So for example, it could have 4 single bond. Okay, so for example, it is bonded to 3 of the hydrogen and 1 fluorine. Okay, so this is what is meant by hydrogen and halogen form single covalent bond. Okay, so here for the case of hydrogen, the only one will form single covalent bond. The same goes for fluorine. So hydrogen itself, because the maximum number that it can contain is 2 electrons. Okay, so for the fluorine, okay, so even though it has single covalent bond, it already achieved octet because of the presence of lone pair. So actually we have lone pair here. But for the case of organic chemistry, usually we didn't draw the lone pair itself. Okay, so this is for the case of carbon and hydrogen. Okay, next is oxygen has 2 covalent bond and 2 lone pair. So for the easiest example to show, if we have our metanoic acid. So for the case of metanoic acid, which is our carboxylic acid itself, for example, okay, again, for the carbon, so we have double bond O, OH, and then H here. Okay, again, carbon will have 4 covalent bond. So carbon here have 1, 2, 3, 4. Okay, so that is for the case of carbon. But then oxygen has 2 covalent bond and 2 lone pair. So even though oxygen here, we can see that it has 2 covalent bond. So either in terms of 1 double bond, or for the case of oxygen here, it has 2 single bond. Okay, but then again, the oxygen here will achieve octet because actually it has 2 lone pair present. Okay, for the case of the oxygen, why it preferred to have 2 covalent and 2 lone pair, it is because it wanted its formal charge to be 0, the lowest possible formal charge. Last but not least, we have N, nitrogen. Nitrogen has 3 covalent bond and 1 lone pair. So for example, again, I'm going to show you for the example of amine. Amine or methanamine, we have carbon. It has 4 bond. Okay, and then it is bonded to nitrogen. Okay, nitrogen, it prefer to have 3 bond. So here, 3 covalent bond. 1, 2, 3. And then 3 covalent bond and 1 lone pair. Okay, so lone pair here to the nitrogen. Carbon will form 4 covalent bond, but this covalent bond, it could be 4 single bond, or it could be double bond and single bond as well. Okay, but for the case of oxygen and nitrogen, oxygen form 2 covalent bond and 2 lone pair for the oxygen. Nitrogen prefer to form 3 covalent bond and 1 lone pair. Again, this exception is because the atom want to achieve the lowest possible formal charge, which is 0. And I'm just going to add one more compound. We have HCN. So HCN is how we draw it. Okay, HCN. Again, carbon already achieved octet because we have 4 covalent bond. 1, 2, 3, 4. Okay, for the nitrogen, we have 3 covalent bond. 1, 2, 3, and 1 lone pair. Okay, for the hydrogen and halogen, again, we only form single covalent bond. Okay, so how do we draw this one? Again, this is from the previous semester, which we draw our Lewis structure. So again, this is an example of structural formula, which is a chemical formula that shows how the atoms are bonded to each other. Okay, but then again, for this 4.2, we're going to look further. The structural formula is divided into 3. We have expanded, we have condensed, and then we have skeletal structure. Okay, so let us start with the expanded structure. For example, a hexane. For expanded structure, it will show all the covalent bonds between the atom. So for the hexane, it's actually an alkane which follows CnH2n plus 2. Okay, but then how to draw it? So again, we have hexane C6. It means that we have 6 carbon present. 1, 2, 3, 4, 5, 6. Okay, and then how about the hydrogen? Okay, so again, based on the previous one, we have stated that the carbon will form 4 covalent bonds. So make sure that each of the carbon will have 4 bonds. So this carbon here only have 1 bond. So what we're going to add, we're going to make sure that it has 4 bonds lah. 1, 2, 3, 4. Okay, so 1, 2, 3, 4. This is for the first carbon. The second carbon, it has 2. So it needs 2 more. Okay, and then I'm going to complete all of it. It must have 4 bonds for each of the carbon. So all the carbon has formed 4 covalent bond. Okay, now we're going to bond the hydrogen to the carbon present. So where's the hydrogen? Hydrogen will be present all around here lah. So here is the C6H14. Okay, so again for the expanded structure, we're going to show all the covalent bonds between the atom. So C 1, 2, 3, 4, 5, 6. H we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So for the expanded structure, we show all the covalent bond present. So that is for the example of hexane. Okay, next we're going to look for the case of condensed structure. Condensed structure does not show the single bond between the carbon-carbon bond and carbon-hydrogen bond, except for cyclic. Okay, so later on for the condensed, we're not going to show all the single covalent bond present here. Okay, but then the double and triple bonds are shown for the double bond here, or triple bond. Okay, and all atoms that are attached to a carbon are written immediately after that carbon. Okay, so we have here carbon 1, 2, 3, 4, 5, 6. So we're going to start from the left to right. So at the start, we have CH3. So that is what is meant by all atoms that are attached to a carbon are written immediately. So this hydrogen is bonded to this carbon, so CH3. So we have written this one. Okay, so next what we have is we have CH2. For the condensed structure, we're going to follow based on the expanded. So CH3 is because this one, CH2 is because of the first one here. Okay, next we have CH2. We have 3 more of the CH2. So we're going to write down again. Okay, so when we look here, we have CH2 4 times. So that's why we're going to write down it 1, 2, 3, 4. And then at the end, okay, we're going to write down CH3 again. So this is the condensed structure for hexane C6H14. Okay, we didn't show any of the carbon-carbon or carbon-hydrogen single bond. So this is one way to write down the condensed structure. Actually, you can simplify it further, because actually, as we can see here, the CH2 is being repeated 4 times. So we can also write it down as CH3 and then CH2. Okay, we're going to make a bracket and then we're going to write down 4 and then we're going to finish up with CH3. Okay, so carbon we have 1, here carbon we have 4, here we have another carbon, so 6 of the carbon, and then hydrogen 3 plus 8 plus 3 more, which is equal to 14. So there are 2 ways to write down the condensed structure and both is accepted. Okay, next we're going to look at skeletal structure. Okay, for skeletal structure, we choose only the carbon skeleton. The carbon and hydrogen atoms are not written. So for the case of expanded and condensed, we show the carbon and hydrogen present. But for the case of skeletal, we will not show it lah. Other atoms such as oxygen, chlorine, nitrogen, hydrogen that is attached to oxygen or hydrogen that is attached to nitrogen, and O2 are shown. And the bond is represented as line. Okay. So we're going to draw it in terms of zigzag. Okay, so either zigzag like this or you're going to draw zigzag like this. It is accepted lah. So again, it must be a zigzag line. Okay, so again, we have C6. Okay, so when I draw it here, so for the first line, we have 1, 2, 3. Okay, so when you draw the line, okay, it's fine if you're gonna label it. So here we have carbon number 1, carbon number 2, carbon number 3, carbon number 4. But then again, we have C6H14, so carbon number 5 and carbon number 6. Okay, so just to be safe, just label it, label the line to show how many carbon present. So here carbon number 1, 2, 3, 4, 5, 6. Okay, so that is for the case of hexane. Since we didn't have any other atom, so we don't have to show the atom present in the skeleton because we only have carbon and hydrogen. Okay, so next let us look for the case of butanol. So butanol means that we have 4 carbon, and make sure that for the carbon must have 4 bonds. So again, we're going to start 1, 2, 3, 4, and then for the each of the carbon must have 4 bonds. For butanol means that we have alcohol, or alcohol means that we have OH, okay, for the structure. So OH, again, we have to make sure that it is a condensed structure. Okay, I'm just going to draw at the end here, OH, okay. For the case of expanded structure, we have to show for each of the single bond. So you can't draw it as COH, it's not accepted. The single bond between oxygen and hydrogen must be drawn as well. Okay, so the rest of the bond must be bonded to the hydrogen. So this is for the case of butanol expanded structure. Okay, next we're going to draw in terms of condensed structure. So condensed structure, again, we're going to start from the left to right. So from the left, we start with CH3. And then we have CH2 3 times. But then again, I'm just going to rewrite it again. And then at the end here, we have OH. So I'm just going to write down OH. Okay, so this is for the condensed structure. Again, for the condensed structure, we don't have to show any single bond. But for the case of expanded structure, we have to show all the covalent bond. Okay, so does not show the single bond, just add in your notes. We're not going to show OH bond as well. This one, please add in this one in your notes. Okay, so that is for the case of condensed structure. Next, we're going to look based on the skeletal structure. So how to draw this structure? Again, we're going to draw a zigzag. So zigzag, if you're not sure, then just going to draw the zigzag and then we're going to label it. Okay, carbon actually we have 1, 2, 3, 4. So here I'm just going to label 1, 2, 3. Okay, again, the last carbon. And then for the carbon number 4 here, it is bonded to OH. So I'm just going to label it. For the carbon number 4, it is bonded. Okay, you just can't let it be here as it is, because if you just let it be, it means that this is carbon number 5. But actually, the carbon number 4 here is bonded to OH. So here for OH. Okay. Again, for the skeletal structure, okay, C and H atom are not written. So that's why for the case here, CH3, CH2, CH2, CH2 is not written. But for the case of OH, because this hydrogen is bonded to oxygen, so we have to draw lah, or we have to label it. So this is for the case of butanol. Okay, next we're going to look for the case of example C. Okay, example C, we have propanoic acid is an example of the carboxylic acid. Okay, so how do we draw propanoic acid? Okay, propa is actually, it means that we have 3 carbon here. So 3 carbon, so we have 1, 2, 3. Okay, but then again, for the case of carboxylic acid, okay, it means that it has double bond O and OH. Okay. So after that, you have to make sure that each of the carbon has 4 bonds. This carbon already achieved 4 bonds lah. 1, 2, 3, 4. So we don't have to add hydrogen down here, but we have to add the hydrogen here. For the case of oxygen, again, it will only form 2 covalent bond and 2 lone pair. For the case of organic chemistry, the lone pair is not compulsory to be written. Okay, so the lone pair is just to show that the atom already achieved octet. Okay, so this is the expanded structure, means that we have to show each of the covalent bond. So again, if you draw C double bond O, OH is not accepted. Make sure that between oxygen and hydrogen must be expanded as well. Okay, so that is for the expanded structure. So how about the condensed structure? So again, condensed structure means that we're going to condense the expanded structure from the left to right. We're not going to show any of the single bond. So we're going to start with CH3, and then we have CH2. We can condense it further into COOH straight away, or you could also written it as CH3, CH2. Again, for the condensed structure, we don't have to show the single bond. But for the case of carboxylic acid here, we have C double bond O. So this double bond can be shown in the condensed structure. So what does it mean? It means that we have the structure to be C double bond O, OH. Okay. So both of this condensed structure is accepted, because for the condensed structure, we cannot show the single bond, but the double bond can be shown. So that's why this is accepted. The COOH, this one is also accepted. Okay, so that is for the condensed structure. Okay, so how about the skeletal structure? So skeletal structure, again, for this structure, we have 3 carbon. So when I draw the zigzag line, I'm going to draw it to be this way. 1, 2, okay. But then again, when we label it, we have 1, 2, 3, 4 carbon. We actually have 3 carbon. So the carbon number 4, or this line, could be erased. Okay. And then for the carbon number 1, carbon number 2, carbon number 3. Carbon number 3 is the one that is bonded to the double bond O. Okay, so what happened? You could draw it double bond O to be downwards. Okay. And then on carbon number 3 here, it's bonded to OH. Okay. So this is the skeletal structure of propanoic acid. So this is one way to draw it, or you could also draw it as 1, 2, 3. Okay. 1, 2, 3. So for this one, I show the double bond to be downwards, or you could also draw the double bond to be this way. Double bond here. Okay. So downwards here will be the OH. So both is accepted. Again, what we have is we have 3 carbon. 1, 2, 3, 1, 2, 3. And on carbon number 3, it has double bond O, and it also have single bond OH. Okay. So that is for the case of propanoic acid. Next, we're going to look for the case of bromopentane. So for the case of bromopentane here, we have the structure to be C5H11Br. Okay, but then again, the skeletal has been given to us. Okay, so we're going to follow it based on here. Okay, so when you label here, we have for the C5H11Br, we have 1, 2, 3, 4, 5 carbon, and the bromine is located on the 3rd carbon. So when I draw it for the case of expanded, so first we're going to start with expanded first. 1, 2, 3, 4, 5. Make sure that each of the carbon has 4 bonds. On carbon number 3, we have bromine. Okay, so what about the rest? The rest we're going to fill up with the hydrogen. Okay, So this is the expanded structure. Since Br is this one, you don't have to show B dot R. It's actually bromine is the name of the atom itself. Okay, so this is for the expanded. For the condensed, okay, what we're going to write, again from left to right. So we're going to start with CH3, CH2. Okay, and then in the middle here, we don't have CH2. It's not the same as CH2 from the previous carbon. We have CHBr. Next, after CHBr, we have CH2 and CH3 again. So that is for the bromopentane for the condensed structure. And then this is the skeletal one. Okay, since it has been given to us that the bromine must be at the carbon number 3, so we have to show the bromine to be in the middle. Okay, we can't show it at the end here. So here it has been given to us the skeletal structure. Okay, last we're going to look together is example E, cyclobutane. Okay, cyclobutane given to us is actually the condensed structure. Okay, again, this single bond is shown because it is cyclic. Okay, so cyclobutane, butane means that we have 4. So that's why the shape will be like this lah. If cyclopropane means that 3 carbon, the shape is triangle. Butane is a square. Okay, if you have cyclopentane, the shape is pentagon. If cyclohexane is a hexagon. Okay, but then butane means that 4. So if it's in circle, it means that it is in a square shape. So how to draw it in an expanded structure? You cannot draw it in terms of this way. 1, 2, 3, 4. This is not a cyclic. This is a straight chain. So what I'm going to draw, I'm just going to draw again based on this one. We have carbon. So carbon 1, 2, 3, 4. Okay. Again, make sure that all the carbon must have 4 bond. 1 for carbon 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, 3, 4, 3, 4. Okay, and then we have to show that each of it must have hydrogen present. So this is the expanded version of cyclobutane. If you draw it this way, carbon, 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 and you show the hydrogen, this is not cyclobutane. This is a butane. This is butane. Okay. So for the case of expanded, condensed, and skeletal, we do not change the number of atom itself. We just follow based on what is given. Okay. So here, this is the expanded structure of cyclobutane. Okay. So this is the condensed. Okay. How about the skeletal? Again, the skeletal, we don't have to show the carbon and the hydrogen present. So what will be the structure? The structure will be a square. So this is the cyclobutane. Again, if you draw it to be this way, 1, 2, 3, 4. Just going to label 1, 2, 3, 4. This one is incorrect. Okay, it must be a cyclic structure, cyclobutane. Okay, so that is all for the example itself. So for the example FGH, you may try it yourself.